state machine diagram, processes, threads. So those are the things we'll be talking about, and they are also talking about again sequence diagram and communication diagram. So what are events? So whatever is happening, right? Like they are saying, the changes of the model and the relationship depend on the state of the model. Suppose train number 04010 should depart from New Delhi station before it can arrive in Lucknow station. The two events are casually related. Similarly, train number 04010 may depart before or after train number 04050 departs from Mumbai station. The two events are casually unrelated. Right? So events are also known as the things that occurred. So basically, whatever is happening or whatever is what event is occurring or whatever is going on, that we say that is an event. So UML events, things happen in the form of the model. An event is a model specification that causes something to happen in time and space. So events can be internal or external. Events may occur in synchronous or asynchronous forms. The time at which the event executes is an implicit attribute of the event. One event may occur before or follow another, or the two events may be unrelated. So here, or the two events that are casually unrelated is known as concurrent event. That means simultaneously things are happening. That for that we say that it is a concurrent event. If communication delay between the two locations is greater than the difference in event time, then the events must be concurrent. Right? So there are various types of events. They are saying there are signal event, call event, time event and change event, sending and receiving event. So these are the events they are talking about. So signal event is what? It is a way of expression, transmission of information from one object to another object. That is signal event. So signal means that you are sending some message or something. A signal event happens when two or more items happen at the same time. Various characteristics, instances, relationship and operations are associated with the signal event. So they are saying signal event happens when two or more items happen at the same time. So signals attributes serve as a parameter. Signal event is used for sending and receiving a signal, like a message. So if it is a message between objects, while a signal event is an occurrence in time. You have call event also. It refers to an operation transmitted from one object to another. It is used as a trigger to change the state of a state machine. In this event, the sender sends a message and waits for the acknowledgement from the receiver's end. For example, a customer or user wait for the OTP at the time of some online transaction. So that will be known as a call event. That operation transmitted from one object to another, that is a call event, right? So events are defined by remote control used as manual or automatic. So they are calling it as call event. Then you have time event and change event. So it is an event that occurs at an accurate time or the passage of a time given time interval. It is denoted by the after followed by the parenthesis expression that measures the time duration. Right. So they are saying that any event that occurs at an accurate time or passage of a given time interval. So that will be time event, right? So when the time event is executed after 15 seconds, call will be disconnected. So they have set a time. Time event is according to the time. So they have set a time that after 15 seconds, the call will be disconnected. Right. So a change event is used to denote an event that denotes a change of state or fulfill some of the Boolean conditions. So they are saying some changes when some change occurs, then according to some condition or something, so that is known as a change event. The change event is denoted by when, followed by a Boolean expression in parenthesis. So when time is equal to 11:50 a.m., the event executes and stops the charging. Right. This so there is a condition when when the time is this, then the event will execute and stop the charging. So this is a change event. Right. Then sending and receiving events are also there. Every instance of a class has either a call event or a signal event. The sender is waiting for the receiver if the call is synchronous. If the signal is used, it works at the event of the receiver without anything. So they are saying you have a sending event also and a receiving event also. So whenever a call or a signal event is occurring, so you are sending something, right? Sending some message or receiving whatever. So the sender is waiting for the receiver if the call is synchronous. If the signal is used, it works at the end of the receiver without anything. So at least two objects are involved in the calling and signaling event. The object on which the event has been directed for transmitting or initiating the operation. So that is what they are. For example, when you send a signal push button to the actor communicating with an ATM device, users can proceed on their way regardless of whether the system is sending the signal to the user or not. So in comparison, the sender dispatches the operation and waits for the recipient in the process when the object calls an operation. Right? So that kind of a thing. So they are talking about signal different events. Then you have signals. What is signal? So a signal is used to present an object which is transmitted by one object and received by another object asynchronously. Every signal has instances, attributes, and relationships that perform various operations. A class instance can receive a class or signal event. If the event is a synchronous call event, the sender and receiver are met during the operation. It means the flow of control of the sender is suspended from the receiver flow of the control until the operation is terminated. So in this case, the sender and receiver do not lock. The sender sends a signal continuously without the wait a response from the receiver end. In such cases, the event may be lost. It may activate the receiver state machine or it may invoke a call method. For example, the event is an email sent by one user and received by another user. So they are saying it that signal is just an object which is transmitted by one object and received by another object asynchronously. Right? It is not synchronous; it is asynchronous. So it means the flow of control of the sender is suspended from the receiver flow of the control until the operation is terminated. So the sender and receiver do not lock themselves or do not once they have sent and they will not continue to communicate. So sender sends a signal continuously without the wait or response from the receiver end. So like in email, you send the email, right? So you don't know that he has received or not, or he has checked the email or not, but you are sending it. So that kind of a thing. So common modeling techniques. So modeling a signal family. To build a signal family model, consider all types of signals that can be received by a collection of active objects. Search for common types of signals and put them in an inheritance generalization or specialization hierarchy. Search for polymorphism in these active object state machines. Adjust the hierarchy when you find polymorphism by introducing intermediate abstract signals. So in modeling a signal family, also they are saying that you find out all the signals which are there, which are received, right? Uh, then you find out the common types of signals and put them in inheritance, generalization, specialization, and all that. And then you can also do polymorphism in these objects, right? So that kind of a thing they are talking about. Right, so they are just giving you example like here they are in figure 4.5. They are they are not written inside the boxes, but we just see what they are talking about. Depicts a series of signal that a mobile signal would be able to handle. So they are displaying mobile signal, how the series of signals will be going on. So here it is worth noting that the root signal, mobile signal that is abstract, meaning that no direct instance are possible. This signal has two concrete specializations, network and hardware fault, of which one is more specialized, hardware fault. The network signal only has one parameter. Right. So they are saying you the mobile signal is a abstract. That means the main base class is mobile signal, and no direct instances are possible for that. And there are two types of concrete specializations. That means general. That means you have two child classes: network fault and hardware fault. Network fault and hardware fault, right? Of which more specialized is the hardware fault, and the network signal has one parameter. So this must be hardware fault, this must be a network fault, and this hardware fault is more specialized, so it is further divided. They have not given what further division they are talking about, right? So that kind of a thing. Then modeling exceptions. So consider the extraordinary requirement that could be posed for each class interface and functions of those components. Uh, so we are not talking about that. Here they are giving an example of a hierarchical structure of exceptions that can be simply raised by a regular container type library like the template class. This hierarchy shows the abstract signal exception and consists of three highly specialized exceptions: doubling, overflow, and underflow. As illustrated, the add operation raises doubling and overflow exceptions, and the delete operation raises only the underflow exception. And they have not shown it. So this events and all are not important, right? You just need to know that there are events and there are signals, right? We need to know the state machines, how to make state diagram or a state chart diagram or state machines. So in UML modeling, state machine is a specification of the dynamic behavior of a particular class, object, use cases, and system. So when you create a state machine, the object attaches to the system to become the master of the state machine. When a state machine is used for operation, the operation becomes the master of the state machine. So when you create a blank state machine diagram, it represents the sequence of state of an object, the events that cause a transition from one state to another state, and the result received from a machine is the change of the state. So basically, what you have to do in state machine is you have to take an event like you want to withdraw money from the ATM. Suppose this is your event. That event, what all things will be happening and what all transition will be happening from one state to another, that is what you will depict in the state machines, right? So here, first you should know what is a state. So the state is a circumstance in the course of an object's existence during which some condition is fulfilled, some operation is carried out, or some event is awaited. For a limited period of time, an object persists in the state. For example, in an ATM transaction, the ATM may be in either reading card state, reading pin state, choosing transaction, or performing transaction. So state can be anything, right? State can be like they are saying if you are doing an ATM transaction, so your state can be either the state can be in ATM can be in the reading card state, or it can be in a reading pin state, or if you are choosing some transaction, that is a state, or performing some transaction, that is non-state. So that is what any circumstance which is happening is a state. So a state name should be unique in its neighboring state. A state contains 5 parts: name or input or outcome, behavior, internal transitions, and transitions performed without any state change. You can also have substates, deferred events. So what are substates? A state's nested configuration that includes disjoint or concurrent substates. So you can have a state having substates also. That is there. Deferred events are also there. Collection of events that were not processed in the state but in place of delayed objects handling in a different state. You have initial state. Initial statement, it shows the default starting point for the state machine or substate and is seen as a full black circle, right? So we'll talk about that. And the final state, in this state, machines or enclosures are closed and are shown as a filled black circle with an unfilled circle, right? So like in an activity diagram, we were showing a black circle for the start point, and end was a filled circle inside a unfilled circle. That is a final state. Same way in state machine also, initial state and final state will be like that. Then pseudo state, the first and the last states are known as pseudo states, right? Then they are talking about transitions. Transitions refer to the relation between two states. The first state performs some action and reaches the second state. Transactions are executed when one event is defined and conditions are met. So transition refers to when you change your state. From one state you go to the other state. So that is known as a transition, right? And they can happen when an event is defined or some condition is met. So transition can happen. Transition fire means state reform takes place. That means state changes to some other state. the entity will be executed before the transaction fires. So an object is said to be in the target state after the fire states on it. So 5 parts of transition are source state, event trigger, guard condition, action, target state. So source state is the transition effect on the state. So source state is the state is the but right now you are at source state, right? Then on which the transition has to happen. Then event trigger means a stimulation that can activate a source state to fire when a guard condition is met. So now the event occurs where when the condition is met, the guard condition means that when this guard condition is met, then this event will trigger and some action will be taken. So the Boolean expression is evaluated when the transition is activated by the reception of the event trigger. So this condition will be met, and then the action and executable atomic calculation that may be directly performed on the object that owns a state machine and indirectly on the other objects that are visible to the objects. Then this was your source state on which the transition was happening. An event occurred, a guard condition happened, and then the action was taken, and then you come to the target state. So it is activated after the completion of the transition. So now you have your state has been changed to the target state, right? So that is what they are talking about. Then you also have, they are explaining about event trigger. So event trigger is any signal or any change or call or event which is happening because of which some changes will be happening in the state. Guard condition is any condition or calculation or something like that because of which that Boolean expression either is true or either is false. According to that, your transitions will happen. Action is that whatever true or false according to the condition, whatever action should be taken, that is taken, either you are calling or removing or transmitting or whatever it may be, that action is taken, and then you go to the target state, right? So advanced state transitions also they have given. We are not going for that. I am just showing you. I don't think so. They have given. They have here. They are modeling the lifetime of an object. So here illustrates the state machine for the controller in home security alert device, which is in charge of tracking numerous sensors around the house parameter. So what they are making is a home security alert device state machine, state chart diagram for a security alert for the home machine, and how it is working. So it is actually having sensors around the house for tracking and in the home parameter. So here this dark circle is the initial point or the start. You go to the start state, right, from the initial. Then you are going to the idle state, right? So after 20 seconds, it automatically goes to the idle state. So it is going back to the idle state after 20 seconds, right? So from the idle state, when a command is, when attention is, some signal is passed, that means some command is given. So this command is given, right? So that action has to be taken, right? So start idle, and some if that command goes back to the idle state, it creates a alarm system, right? If something is happening, so the alarm system is triggered. So from the idle state, it goes to the alarm system, and then it checks, right? In this a separate part is also made again at the initial state. Then checking is done, then calling entry or call center, right? Then waiting. So this is initial set alarm, and final is clear alarm. So when your everything is okay, you are waiting for the call center's response, or everything is okay or not. After everything is okay, it again goes back to the clearing and to the idle state. They have made a simple example, but we can go for another example for the state chart diagram. Like here, they are making a state that a door goes from through during its lifetime. So here, a normal door of your house. So here your initial or starting point is there. Then here you come to the open state. So close doorway is empty. So if your doorway is empty, you need to close it. So you go to the closed state, and from the closed state you can go to the open state also. And in the closed state you can go to the lock state also. You, after closing, you can lock it. If you want to unlock it, you can unlock it. So these kinds of transitions they are showing an example of a state machine. Right, I'm just seeing. So here they are saying uh, uh, a state machine diagram may include sub machine diagrams as an example. So this is a sub machine diagram. Inside a state machine you are making a sub machine. So here ATM system has been portrayed here, I think. So this is the initial state. You go to a sub machine, and then again initial state is there. So here you enter the pin in the ATM. So it for checking the pin. So you enter the pin, right, and then a condition. Again, the same thing like a flowchart. The condition is there. So if the pin is okay, you go to the end state. If the pin is not invalid, then it goes back to the enter pin state. So if your pin is okay, from this sub machine you go to the next part, that is search the network. When if the network is found, you are ready, right? And from the ready state you can go to power off, right? Maybe your it may be your mobile also. Then search the network, power is off, then you also go to the off state, and from this enter a valid pin also, you can go to the off, power off state. So that is what they have displayed. Then another example, if we take, so here, yes, your voice is not coming. Who was that? Hello?
Ma'am, maybe by mistake they unmute him.
Okay. So this example, they are talking about state chart diagram of a washing machine. So suppose you are at the initial state, and you have a inside substate you have created. So this is your machine running. So first part, it goes to the washing state, then to the rinsing state, then to the spinning state, right? And then after spinning, the end of the state is happening, the final state, right? If somehow your washing machine is not working, right, you can also go from all these states. You can also go for the power. If some power cut happens, so it goes to the power off state, right? When power restores back, you can go back to your original state, right? So this kind of a thing they have displayed. So these things you can show in your state chart diagram. Other examples, if we see, so here initial state is this, then your idle state is, initial state of the object is this, then send order request. So this is order management, some order management system. So you are sending order request, right? So if you're sending order request, if it is normal, select normal or special order. So you will select a particular order. You can give a condition also if you want. If you want to select a special or normal order, yes. Raja, can you mute your mic? So you can select as normal or special order, right? After your selection, you confirm the order. The order confirmation is the next state, and then you dispatch the order, that is the next state, and the complete transaction happens here. If somehow send order request, some abnormal exit happens or some failure happens, then also it goes to the final step. So this is how you portray a state chart diagram. This is how you show a state chart diagram. Just an example, right? So now, apart from the state chart diagram, what else is there? Is your processes and threads they are talking about. So an active class is an object that has a process or thread. The class can monitor the operation of the process, while an active class is a class of instances. A process itself is a heavyweight flow that can run concurrently with many other processes. So thread is a lightweight flow. If some of you have must studied operating system, so you know what is a process. A process is a uh, anything which is in running state, right? Any program which is in a running state is a process. And what is a thread? A thread is the lightweight process. That is, a process can be divided into threads. So smaller part of the process will be a thread, a lightweight flow that can run concurrently with several other threads in the same process, right? So class is represented by a rectangle of thick lines. Threads and processes are described as stereotype active groups. So that's how they are talking about. So they are talking about class and events. They are talking about process and threads, right? Then what is the communicate when objects participate with one another by passing messages from one to the other, it is called communication between objects. So there are four possible communication of interaction with passive and active objects, as a signal can be transformed from one inactive object to the next. Second, a message may be sent from one working object to the next using intercrosses correspondence. And third, a message should be sent from an active object to an inactive object. Fourth, a message can be transformed from a passive object to an active object. So you can have communication also between the objects or the processes or the threads, whatever you can say. Synchronization, where also you have to do what is synchronization. So visualize the various control flows that are created temporally through a concurrent system. If a flow goes through an operation, we state that control locus is in the operation at a specific time. The problem occurs when more than one control flow is concurrently executed in one entity. So suppose there is a situation like you are booking a ticket in a railway reservation, and some other person is also booking at the same time. So sometime what happens, if your process is waiting for some event to trigger or some action to be taken, the other person is also waiting for that event to be triggered. So they are not synchronized with each other. Matlab, you have to let one person wait and the other person have the complete transaction. So sometimes what happens, it creates a deadlock situation. So we need to synchronize the process so that, right, one action is completed, then the other action is taken care of. So that kind of a thing is required in a synchronization. Otherwise, if failure occur and are not dealt with adequately, it may result in many race conditions and interference. Right. So that means you are waiting for some resource or waiting for something to be booked, and still it is not getting booked or something is happening. So that will be a problem. A deadlock situation will happen. So we don't need that. So for that, we need to have synchronization of the processes. Yes. Who's there? So this is what they are talking about here. We're not going for that. The other diagram which I'm just going where your diagrams are there. We should focus on. So here again, they are showing the state chart diagram in UML. So what is state chart diagram? Explains the different states of a component in a system. It can be used to define the different states of an object, external and internal event control these states. So one of the essential diagrams in UML modeling complex aspects of the process is the state diagram. So that is what we had seen right now. The examples. This is state diagrams only. This is a state diagram, right? This is what you have to do. The state diagram. These are what you have to do. Draw, right? So they have given the purpose of a state diagram. State diagram depicts a flow of control from one state to the next state. The term state refers to a situation in which there is an object and it changes when some event is triggered. The main purpose of the state diagram is to design an object lifespan from development to termination. That is what is a main thing. So that is what they are talking about. Then they are again explaining what is state, what is event, what is transition, right? Then how to draw, like here, this is a student state in a semester. So student states in a semester. So, for that they have created a state chart diagram. So your initial starting point is there. You go to the registration state. Then your term end starts. That means your semester starts. You are being taught. You go to the being taught state, right? If student drops out, then then again he goes to the final state, right? This black circle should be inside this. So by mistakenly it should be a dark circle and outside a hollow circle. So that's if he continues the class and class ends, so he's being taught. Basically this should not be being taught. This should be your end of semester or your examination, and then your final end of the state is there. And if your registration also cancelled, then also you go to the final state, ending state. So this kind of a thing you are portraying in your here. They are saying shipping process. So in the shipping process, you start, shipment is collected, and you go to the filter purchase order. Then you go to the confirm bill with purchase order state, get the purchase order, and from the ship investigator, you go to, from here you go to the ship investigator later on, right? Then if it's a paper shipment, then you generate shipment fault notice. That means irregular shipment is there. You generate a shipment fault notice, give the notice is prepared, send the notice to the supplier, and end. Notice is sent. If it is okay, confirm bill and purchase order is okay, you go to the ship investigator and then you end. So something like that. So this is your state chart diagram which you need to draw. That is so remember that you need to go after your check progress questions also. Just go through the check progress questions always at the end of your units, right? So this was about state chart diagram in block 1 unit 4. Right. So then the next unit in block 1 is architectural model. So in architectural model, we'll be talking about component diagram and deployment diagrams, right? So they are just talking about what is modeling, right? What is a model? A model is an abstract representation of a system which promotes a better understanding of its representation. A model is a small, you can say, prototype which we create for a system. It helps to give better insight into the development of the system among communication of project team members. The model also gives us an overview of the system planning, design, testing, and implementation. So that is what they are talking about. Then what is modeling? Modeling is a critical part of any developing software project. It is always leads to the final deployment of a good software system. So if you want to understand the system in a better way, you need to need the modeling of the system. The modeling helps to visualize and control the system architecture. So basically you are making this prototypes, the same thing. So they have given the different definition, like Grady Booth said, modeling is a central part of all the activities that lead up to the deployment of good software. So that is what is there. So you have different types of modeling, like here they are talking about architecture modeling. Right. So the architecture of software deals with the design and implementation of the high level structure of the software. It involves the association of various architectural components to show the correct functional and non-functional requirements of the system. For a better understanding of the architecture of a software system, there are different diagrams and models. Among these, architecture model has its own importance. Various modeling elements and techniques are required to describe the architectural model. So, architectural model, they are talking about that the software, that the implementation of higher level software, you need the architectural model. So you need to show the components and other things. So that is what they are talking about. So the aspects of the architecture model, yes.
Ma'am, actually, in this like chapter, what are the main topic that we have to cover here?
See, in this, you should know what are the different modelings, and generally, here in this, you need to know the different diagrams which are there, like
Okay.
component diagram, deployment diagram. That are the most important things.
Okay.
Right. If you go for your question papers, remember that you should download your question papers. I may not have told you, I don't know. So you can go for the question papers, like June 2024 question paper is available right now, right? And from here you can go to SOCIS, School of Computer and Information Sciences, under which your BCA, MCA, PGDCA courses are there. So go to MCA new, right? And you can go to object oriented analysis and design. You can download previous five question papers which are there, so you can download them. So this is your question paper, right? So like
SOCS.
what?
What we write? SOCS.
SOCIS, SOCIS,
Okay.
School of Computer and Information Sciences. So this question number 1 will be compulsory, right? It's a 3 hours paper, and apart from the rest, 2 to 5, you can attempt any 3 from the rest. So here, like they are the questions they are asking is object oriented. What is object oriented modeling? What are the advantages of that? What are the stages of object oriented modeling? What is time critical system? Right, we'll talk about that. Also explain the need of synchronizing time critical system. What is persistent object? What is transient object? What are derived attributes? Right, what is design optimization? What is association? We have seen earlier. Explain one-to-one association with the help of a class diagram. Also explain how it is implemented. What is collaboration diagram? We'll be doing collaboration diagram. Explain how methods are created from collaboration diagram. Design, what is design optimization? That is later on. What is abstraction? We have seen that. Explain how abstraction results in modularity. Also explain the need of inheritance adjustment in the design process. What is DFD? Again, another diagram, right? What are the advantages of DFD, and what are draw 0 and 1 level DFD for online examination? What is dynamic model? Right? Explain the use of dynamic model with the help of a suitable diagram. What is use case? Another diagram. What is use case diagram? Explain various components of use case diagram, and you have to draw the use case diagram for online examination. Then write short notes on aggregation, integrity constraint, implementation control, object model. These kinds of questions come. So generally, diagrams are the most important thing which are there, right? So that's why you should focus on the diagrams more.
Okay. Thank you.
So you should read, you should know all these things theoretically, architecture modeling and all that, but diagrams are the most important things. You should know the definition. What is the advantage of that diagram? What kind of diagram it is? A behavioral diagram or a structural diagram, right? So that thing you should know. So we are doing architectural modeling. So architectural modeling, they are talking about the dynamic aspect of the architecture model is is represented by a collection of component and connection configurations which are controlled by nodes. The dynamic aspect is suitable for handling the runtime modification of the structure of the system. So basically, architectural modeling is similar to, you can say, component diagram or deployment diagram, where uh, uh, you are showing that this is your server, these are your computer connected to the server, how they are how they will your system will be there, final system which runs will be there. That is what architecture modeling is. And the functional aspect of the architecture model includes the system functions and the data flows, interaction between them. It defines how the functions will operate together to perform the system goal. So functional aspect will be component diagram, and dynamic aspect will be your deployment diagram. So we'll talk about those diagrams also later on. Then you also have logical architecture. If you want to understand the structure and organization of the system design, we use an architectural view, which is also known as logical architecture, logical view. So logical architecture starts with the end user's functional requirement and provides a top-down abstraction of the system overall design. So logical model provides a static view of the objects and classes of the system. Object-oriented systems intend for layered architecture. So it is concerned with the functionality that the system provides to end users. Right. So UML diagram used to represent the logical architecture for object-oriented system include class diagram. So the logical architecture is shown by a class diagram, which we have already seen. Object diagram also we have seen. Sequence diagram also we have seen. Activity diagram also we have seen, and state diagram also. So these are showing you the logical architecture. These diagrams show you the logical architecture of the system, how the logic is working inside the system, right? Right. So these activity, class diagram, sequence diagram, state chart diagram, object diagram are logical architecture of the system. Right. So you make a class. This is a class diagram they are showing. So logical architecture of banking management system as a class diagram. So how they are showing is you have a head office, right? Your attributes are branch name, branch code, and your operations are add branch, delete branch, get branch, right? And the next class is bank or branch. You have bank code, bank address, and bank manager as the attributes, and add account, delete account, get account as the uh, methods or procedures or operations, right? So branch or bank is a part of the head office. So there is without the head office there will be no bank branch or something. So composition is there. This is composition association, not aggregation. Composition, complete dependency on the this. Then uh, here they are showing here this should be a aggregation, not a what you say, what is this, not generalization. Here it should be aggregation. Hollowed this diamond, hollow diamond should be here. So accounts are part of the bank, right? That to show that you should have a hollow diamond here for aggregation. So account class is there, account number, account balance, account description, and add account and delete account operations are there. And account, you and I have another class called statement. Date and content will be there, which is account has a relationship with statement. You can create an statement from the account, right? And then there are two types of account. This is generalization. This is correct. So there are two types of account: current account and saving account. So you can add a customer, delete a customer. Here also you can add a customer, delete a customer. And this current account and saving account is connected to the customer. So customer can be having a current account, customer can be having a saving account. So that kind of thing. So this a simple banking system they have shown through a class diagram. So this is the logical architecture of a system. Right. Then you have physical architecture. So physical architecture models are the system's dynamic runtime architecture. It shows the configuration of the topology of the software components on the physical layer as well as the physical connection between these components. So the physical connection means that how the hardware will be connected in your system. That will be the physical representation, like in a deployment diagram, which we will see. So this architecture supports a physical view of the system, and the deployment diagram of UML is used to represent it. So the deployment diagram will be the one which will be used for the physical architecture of the system, right? So these are the things which they have given you. So here now we are talking about the implementation diagrams, which we will talk about. The diagram which is closely correlated with the use case is the implementation diagram. The purpose behind this coupling is to highlight which type of design element will implement the functionality of use case in a novel system. So this diagram provides the physical environment of a system. The implementation view of the system incorporates the components that are used in the system, physical system. So you have two diagrams here in the implementation. One is a component diagram, the other is a deployment diagram. So component diagrams are used to show how the physical components in a system have been organized. It shows the set of components and their relationship in the system. It helps in understanding if the system function requirements are covered by planned development. So the relationship among components are called dependencies. So this diagram models the physical aspect of the system, including software components, source code, runtime code, and executables. Right. So if you see here, generally a component diagram is a collection of vertices and arcs. The essential components of component diagram are component, interface, ports, and connectors. Right. So component is this kind of a thing is a component. In a component diagram, a component represents a reusable piece of software. A component can be your program or sub program, right? You divide your complex program into sub functions or sub programs. A component can be a reusable piece of software or sub program, right? So and is the physical and replaceable unit of the system, right? So this is how a component is shown. So according to Grady Booch, at the lowest level, a component is a cluster of classes that are themselves cohesive but are loosely coupled related to other clusters. So basically, a collection of classes will be a component, right? So components are represented as rectangle with tab having the same name of the object in it. The component may also contain other components, so you can have other components inside this component also, right? So components do not directly depend on other components but on interfaces. Dependencies may also exist among the components, which cause changes in component due to changes in one or more components. So it represents by a dashed line in the component diagram. The component name should be unique in the specified component, right? Then you have interfaces. Now to connect two things like bank, here banking system is one component and bank customer is the other component. To connect both of them, we use interfaces. So components of the system use interfaces to communicate with each other. It defines the components interaction details. It is a collection of operations that are used to specify a service of a class or a component. The interface are shown in the ball and socket notation or as a typical class with the stereotype of interface. So in interfaces, the ball notation is used to specify the component's functionality. A component collaborates with other components through well-defined interfaces that specify the system's functionality to the environment. So how both of them are interacting is through this interface, right? Then you have ports. So ports are used by the component for its interaction with its environment and also to control the implementation of all the operations in the component. Along the edge of the component, a port is shown as a small square like this. This is a port, right? Ports provide encapsulation to the structure classifier. Ports have public visibility, but components may also have hidden ports. Interfaces may be linked to the port, but one-to-one relationship between ports and interfaces is not required. So generally, ports are unnamed, but you can provide the name as port name, yeah, port type, right? So these are ports. Then connectors are there. A connector is used to show a link between the ports of the components. If it also specifies the communication between two or more classifiers. If one port provides the interface required by the other port, they can be linked together. There are mainly two types of connectors, the delegation connector and the assembly connector. A delegation connector links together the ports of a part and port of a component, thus providing the interface. Delegation connectors are used when ports inside the composition need to be connected with ports outside the composition. And there is another which is assembly connector. It connects two or more components that define services provided by one component to other. So like this, you can show that this port of one component is connected to the other port of the component. Direct connect. Right now, example of a component diagram of an ATM system they have given. So this is ATM machine component. This is customer console component. This is card reader component. This is database component. This is client console component. Web page component. So these are the components they have given. So this is your ATM machine. So ATM transaction happens in the ATM machine. Then ATM machine is connected to the bank database, so you can get the account information from the bank database, right? And then ATM machine is also connected to the customer console, that is the monitor or the screen, right, where the customer will enter its things. So then the customer control is connected to the card reader, right? So card reader component will read the card of the customer, right? And it is connected to the bank database also to check whether the credentials provided by the customer are correct or not. Then card reader is also connected to the web page also for online transactions. If you are doing online transactions, you can have a web page also, and it is also connected to the database for checking the credentials. And client control. If you are doing client control transaction, you can do it uh, uh, at a client console provided by the bank at the ATM, right? Or you can do merchant transaction, web merchant transaction also, where card reader machines will be there, where the customer details will be checked from the bank and the transaction will be done. Or you can do online transaction through the web page. So this is how they have showed you. And at the ATM machine, you can do ATM transactions, right? So this is component diagram. So you need to show the different components in the system which are there. That is component diagram. Then you have deployment. The next diagram is your deployment diagram. To address the static deployment view of architecture, we use the deployment diagrams. Deployment diagrams are related to component diagrams in which a node typically encloses one or more components. Deployment diagrams are used during development of the system. In this diagram, we use to indicate the physical collection of nodes that serve as a platform for execution of a system. Before execution, developed components of a software system must be deployed on some set of hardware. Deployment diagram, it represents a configuration of running time nodes and components that live on them. So basically, in a deployment diagram, we show the physical architecture, that what all components you will have in your system, server, web server, or whatever, nodes and all that. So deployment diagram consists of nodes and their relationship, where a node may consist of one or more artifacts. This diagram helps us in the allocation of artifacts to nodes in the physical design of a system. So what is an artifact? An artifact represents physical entity that is used in software design or produced by software development process, like your DLL file, banking configuration, or whatever file is there, which will be put in your system. So as artifacts are physical entities deployed on nodes, devices, and executable environment, it is the source of a deployment to a node. So that is the artifact. Then node is just like component. It is an important building block in modeling the physical aspect of a system on which artifacts are deployed for execution. It exists as runtime. So node will be a simple server system or a normal client machine, right? So this is how a node is represented, right? Then connections, communication is required among nodes in the deployment diagram. Node communicate with each other via messages and signals through a communication path indicated by a solid line. So like this. So one web server is connected to the client console. These are the two nodes, and they are connected through a line. So this is known as your connections. So communication path may be unidirectional or bidirectional. Each communication path may include an optional keyword label that provides information about the connection. So that is there, right? So connections is there. So here they have given you example of a deployment diagram of banking management system. So if you see here, you have a node called application server. Another node is there, database server. Then you have console. Sorry. So we what we were saying is, so these are the nodes, and if you see in the application server, you have bank statement. This is one component. You can show the software part of your system also, that you have different components. So application server has bank statement component, fund transfer component, client check transfer component, and it is connected through LAN to the database server. And the database server has a account detail component and customer detail component. and that is connected to the different network servers apart from them. And then these client consoles nodes are connected to the web service to the application server. This is how they have shown you a deployment diagram. So you have to show the physical part of it, that these are the nodes or these are the components which are there, software components as well as the hardware components which are there for your system. That is what you show in the deployment diagram, right? So do you have any doubts in these two diagrams? Anybody? Component diagram and deployment diagram. Anybody has doubt? In the practical sessions, we will be doing the different diagrams which are there. We will be seeing the different diagrams which are there, right? So we will be practicing that what all diagrams we can draw for the component, for the deployment, and other thing. Then you also have collaboration diagram, right? So collaboration defines an interaction and describes how the elements work together to provide the system's behavioral requirements, so that it must be larger than the combination of all elements. So here the combination of elements may be classes, objects, interfaces, components, nodes, use cases, or other elements. So even collaboration describes the dynamic interaction of classifier instances, though it also has both types of dimensions, structural as well as behavior. So collaboration diagram, with the help of collaboration diagram, you can wire all components together and complex system can be represented in a simple illustration. So in a collaboration diagram, we define the structure of collaborating elements, which is known as role. The role is played by instances. The diagram represents the association and interaction among these instances also. So this is a collaboration diagram. So this we have seen earlier also. So in a collaboration diagram, like here, they are representing banking system. So in a banking system, you have customer, cashier, clerk, account, suppose, right? So what all things are happening, what messages are passing between them. So the customer first requests for an amount to the clerk. So first message is this. Like in a sequence diagram, you have vertical sequences of things happening. Here we will be passing messages and showing that first what messages pass, then second what messages pass. This way we are showing. So customer first requests for an amount to the clerk. The clerk checks the balance in the account accordingly, right? Then the account, if it is available, then the third message is amount available, and it is passed to the cashier, right? And the cashier enters the amount, right? And then the fourth message is cashier enters the amount, and then the account is updated. Update the account accordingly. The cashier updates the account accordingly after debiting the amount, right? And then the deposit, the amount is issued. The amount is issued to the customer, and he takes the cash, and the amount is printed. Right. So one after another, you have to show that how the messages are passed from one person to the other, and how the information is there. That is what collaboration diagram does. I know.
Excuse me, ma'am.
Yes.
Ma'am, in this diagram, the relationship between cashier and account. So
Yeah.
the arrow should be reversed, na? Cashier will
It should
update
be
the account.
reversed. It should be reversed. The cashier updates the account here, so it
Ma'am.
should be reversed here.
Ma'am.
Right. And then the cashier enters the amount and issues the amount to the customer, and then he takes the cash, and then a receipt is printed.
And ma'am, there must be one another arrow if the cashier has to deposit the customer's account.
That
into
will
his
be,
account.
they have shown here deposit amount. They should not be there. If then you can make another thing, that if he wants to deposit the amount, right? If the customer wants to deposit the amount, that will be after printing this 9, then he wants to deposit the amount. After 9, 10 will be he wants to deposit the amount. Then he again gives the request to the customer for depositing, and then the clerk deposits the amount in the account, and the account is updated, and he takes the print receipt.
Okay, ma'am.
That will be
Thank
the
you.
separate part. They have not shown it like that, but that should be the separate. After the 9, your next transaction, you can do the deposit amount. And no, I have the collaboration diagram here or not. So we have seen yesterday also, no, the sequence diagram and collaboration diagram. Yesterday also we have seen that. So sequence diagram is like this, like this. From vertically, we are showing that this message is passed to the next, like that. We were showing it like this in a sequence diagram. But in collaboration diagram, it is like this. That from one person to the other, one message is passed, and this kind of a thing. So an example is like here they are making a reservation in a train. So make reservation and train. If seat is available, it is reserved, and a confirmation is sent to the person. Something that kind of a thing. So message should have numbers. The messages should have numbers, that what messages are passing from one person to other with a numbering. That is collaboration diagram. Right? So that is one part of it. So remember that I told you that each unit has check progress questions. Please read the check progress questions, and the answers are given at the unit's end. So here they have given you the answers for each questions they have asked. So just go through them. Check progress 2 is there. So this is they have given you the main advantages of component diagram. What is the main advantage? And they have shown you component diagram for online banking system. So here they have bank account component, customer component, saving account component, current account component, here credit card component, debit card component. And this is your interface. So bank account, you can do cash withdrawal with the debit card. So that is there. You can do credit card. All credit card is also connected to these are ports. This is an interface. So this is how they are showing. Again, customer and bank account are also connected with a port, right? These components are connected. Then the bank account, you can have a saving account component and a current account component. So these are the components which they have shown. This is a component diagram they have drawn for the online banking system. So they have given you answers to the different thing. You also have the advantages of what are the advantages of deployment diagram, right? And this is your deployment diagram for your ATM system. So here you have ATM node, cash dispense node, display node, keypad node, log device node, card reader node, receipt printer node, network interface node is there, and network interface is connected to a network device, and that network device is connected to the bank server. So you have network connection here. So ATM node, the ATM customer interface, the ATM node, the customer. So they have also given that what will be the processing power, or the node will have what kind of processing power. So they have given a minimum one. You can give whatever. So they have given that processor should be 200 megahertz, Pentium, and memory 64 MB, but it is higher than this right now, right? So ATM node has cash dispense machine node. It also has log device. It also has card reader. It also has display. It also has keypad and receipt printers. All is connected to the ATM, and then it is also ATM is also connected to the bank server. So this is how deployment diagram of an ATM system they have shown. So these are the two diagrams which are important to you. So remember that whenever you are studying for object-oriented analysis and design, you should know what is object-oriented modeling, object-oriented technique, why object-oriented analysis and design is important, what is the use of using object-oriented design and modeling, right? And then you should know the UML. What is UML? Unified Modeling Language, and what are the different concepts of object-oriented technique, right? The polymorphism, inheritance, abstraction, all these things you should know that. And then you should know the different UML diagrams. The different two types of UML diagrams are there: behavioral diagrams and structural diagrams. Structural means static and behavioral means dynamic diagrams. So structural diagrams are your class diagram, then object diagram. Those are your structural diagrams, and in this part you have behavioral diagram, you have sequence diagram, collaboration diagram, deployment diagram, right? So all these diagrams are your so all these diagrams, your definition of the diagram, what is the use of that diagram, and what are the advantages of that diagram, and how to draw that diagram. You should know that for the examination. This is important. So this was your block 1, right? This was your block 1 from unit 1 to 5. They have just given you different aspects of the system, and then you have, and what we'll do is right now your next class is at 11 o'clock. We'll take a break, right? And we'll come back at 11 and we'll continue with the next unit, that is object modeling. Now your further explanation of the system will be there. What is aggregation, what is composition, further explanation will be there. What is generalization? So we will talk about them in the next class, right? Anybody has any doubt or anything? Anybody has any doubt?
Only one block has
Yes.
completed. How many blocks are there in the subject?
I think 4 blocks.
Okay. Okay.
So we are going for the second block today. So everybody has put their name and enrollment number in the chat box for attendance. Any person is left? Anybody who is left for attendance? Any doubts? So we'll meet at 11 now for the next session. Anybody who has doubt? Nobody is left. I'm copying the attendance now. I'm just then we'll meet at 11. I'm not stopping the session, right?
Okay.
I'm just muting my mic and then we'll meet at 11. So good morning again. We're just starting the class again.
Good morning, ma'am.
Good morning.
Ma'am, excuse me, ma'am. Ma'am, I have 2 doubts, ma'am, before starting the class, ma'am. If you
To what?
2 doubts, ma'am, regarding lab or practical exams, ma'am. If you permit
Yes.
me, ma'am.
Yes.
Ma'am, actually, we have to fill the examination form, and today is the last date. Ma'am,
Yeah.
So, ma'am, what will be the venue of these lab or practical exams? This is MCSL 222 or 223, ma'am. 222
You are in OL mode or ODL mode?
Ma'am, I am in OL mode, ma'am. MCA OL, online mode, ma'am.
For OL mode, your practical will be conducted online,
Okay, ma'am.
right?
And
So that will be conducted by, you are under which RC?
Ma'am, RC Regional Center 3, ma'am. Delhi 3, ma'am.
So Regional Center 3 will conduct your practical examination online
Okay,
through
ma'am.
Google Meet or whatever.
Okay, ma'am.
Right?
And
They will
ma'am,
send. They will send you a email. I think that practical exam will be conducted in July. I think July end or something
okay, ma'am. After the exams, ma'am.
after the theory examination.
Okay, ma'am. And ma'am, what we need to fill in CBT computer based test or pen and paper mode, ma'am? Do we
That
need
you
to
decide. You what for CBT examination only 2 centers are available:
Okay, ma'am.
Delhi or Noida.
No, ma'am. Regarding these practical exams, ma'am, lab exams only.
Actually, the examination form which you are filling is actually asking you to fill CBT or paper based, right?
Ma'am, right, ma'am.
Right. So
Ma'am.
that is for theory examination generally,
Okay, ma'am.
right? Practical examination by default for OL it is online mode,
Okay, ma'am. Okay,
right? So what you are filling is for theory examination. You want it in CBT mode or you want a pen paper mode.
ma'am, right, ma'am. And
Right.
ma'am,
For
ma'am,
CBT, only 2 centers are there, Delhi and Noida, because
okay, ma'am.
computers will be available at the centers.
Ma'am.
So there are only 2 centers, and for pen paper mode, there are all over India. There are cities where exam centers are there.
Okay, ma'am. Ma'am, one another doubt is regarding assignment, ma'am.
Hmm.
Because what about the Viva, ma'am? We are not getting anything about the Viva. And when will it be conducted, ma'am? After the submission of assignments?
Actually, sometimes Viva is not conducted. You are given the marks accordingly.
Okay, ma'am.
Right, and if they conduct the Viva, they will inform you on email that Viva will be conducted for assignment, and then you can join. It will be online mode only
Okay,
on
ma'am.
Google Meet. They will
Okay.
take 2 or 3 minutes of your time asking you questions, and then they can
Mm. Ma'am, actually,
ask you.
sometimes we don't get the information regarding the conduction of these online
That's what
Viva.
I'm saying. If they are not conducting the Viva for the
Okay, ma'am.
assignment, they will give you marks accordingly,
Okay, ma'am. Okay,
right?
ma'am. Right, ma'am.
If they are conducting, they will inform you.
Okay, ma'am. Thank you, ma'am. Thank you, ma'am. Good
Welcome.
day.
So the last unit we talked about the different diagrams which we were there. We had seen structural diagrams and dynamic diagrams. Right now we are talking about the advanced things which are there in modeling, object modeling. Right. So we had seen that whenever we are making a system, the main goal of object-oriented design, basically, goal of object-oriented design is to decompose the system. That means you have to divide the system into subparts, right? And then